Hello, I'm ETarte, math teacher. This is the 21st in a series of videos that I'm making for Mark, a high school math student in the Philippines who submitted to me a group of math problems that he needs help with in order to prepare for a math contest in which he will be involved later this week. So I'm doing my best to help Mark. Mark, you asked me, how do we identify the asymptotes of y equals 4 times x to the negative first power plus 3. For the purpose of this problem and similar problems, I will informally describe an asymptote as a line that a curved graph gets extremely microscopically close to out in the distance without ever touching the line. This part of the equation, x to the negative first power, means 1 over x, and so we can write that as y equals 4 over x. And at first, let us consider the equation without the plus 3 that's on the end, and then we will put the plus 3 on later. So we have y equals 4 over x. We can multiply both sides by x and get x times y equals 4. So we think of xy pairs that multiply give 4, 2, 2, 4, 1, along with 1, 4, 8, 1 half, along with 1 half, 8, and so on. We see that neither x nor y can equal 0, but as x gets extremely large, y gets extremely small but remains positive. As x gets extremely small but remains positive, y gets extremely large. And so what I've shown in red, this curve, as it goes out to the right, gets microscopically close to the x-axis, and as it goes upward, it gets microscopically close to the y-axis. And we must also include a second branch, a branch in the third quadrant, where both coordinates are negative, because a negative times a negative is a positive. So negative 2 times negative 2 also equals positive 4, and so on. And here also, this branch gets microscopically close to the x-axis as it goes out to the left, and microscopically close to the y-axis as it goes downward. So this graph has two asymptotes. They are the x-axis and the y-axis. Now we put that plus 3 on the end of the equation. What does that do? Well, for the same x's, the y's of this graph are now 3 units higher than of the graph over here. And that simply raises this graph 3 units. The y-axis remains an asymptote, but the x-axis is no longer an asymptote. Instead, the horizontal asymptote is 3 units higher, as shown by this blue dash line. So our asymptotes for this graph are the vertical asymptote, which is the y-axis. Its equation is x equals 0, and a horizontal asymptote, whose equation is y equals 3. So Mark, that's it for the asymptote problem that you submitted. Thank you for watching.